Hi, my name is Denis. I am a performance engineer at Meta. We're hiring. And I have an internal seminar there, which is really cool. So I gather a bunch of people and we try to write code together once a week. And lately, Paul McKinney have been coming to my stuff. And if you know Paul, he's a world-class expert at log-free. So now I understand a little bit about log-free code. Finally, I understood hazard pointers, maybe. Let's look at this example. So we have some configs that are happening to be updated rarely. Like we have some background threads that sometimes gets an update once every few hours. And everybody reads them. So we want something like a config provider. We have a get method that returns as an accessor, and we have an update method to put a new config. And this is thread safe. Let's go and write a few versions of this. So we're going to start with a standard C++. The best I can do is I can use a shared mutex and a shared pointer. So what I do is my accessor is going to be just a shared pointer to the config. When I want to read the pointer, I first acquire a shared lock, and then I copy the pointer out. And then when I want to update, this is where I get unique lock, and I put a shared pointer in place. Okay. So the problem here is, this is reasonable. You can write this, it will work. However, on our read parse, we do a shared lock. So we have to write into some mutable state somewhere. And we do a counter increment, which is again, all the readers will have to write modify counter somewhere. Not great. Can we do better? There was a proposal, I don't know what's its status, for atomic shared pointer. We have one in folly. It's kind of like combining a shared pointer and a mutex. So when I do config load, it returns me a shared pointer. And when I want to update it, I just do config store of a new shared pointer. Other than that, it behaves exactly the same. This is pretty good. This is ideally better than before. Hopefully they did some smart stuff. This is mostly log-free-ish. But still, we have to do at the very least 1 or 2 increments of the some memory shared between everybody. So what else can we do? In C++, I think 26, we're getting a couple of new primitives for synchronization, for reclamation. One of them is called RCUs, the other is called hazard pointers. Here I'm talking about hazard pointers. There are many possible implementations, but one of the main ideas that they do is, one of the easiest way to implement them is to use thread local storage. So when you want to say, please don't delete stuff, you publish something in your thread local storage. And then when you want to do reclamation, the thing that does reclamation goes to everybody's thread local storage and looks what they have there. All right? With hazard pointers, it looks kind of like this. So our config will have to inherit from hazard object base. It's just to write some stuff in there. The state that we share is actually just one atomic pointer. We don't need any shared anymore because we will do reclamations using hazard pointers. This is our accessor. So accessor has this hazard pointer object. Hazard pointer object is the object that modifies the TLS. So it will write something into the TLS to indicate, please don't delete this stuff. When it's done, it will remove that from the TLS. This is the operation. So in the constructor, I pass this config pointer to the constructor, and this is where most of the magic happen. We call hazard pointer.protect, and it returns us a pointer to the config. What's going on? So the thing is that the word protect makes sense only after you understand this. The actual word that I like is load and protect. It's an atomic operation. So if we just load from the config pointer, it might so happen that on the next line, whatever we were looking at was deleted. This is an atomic operation. It's simultaneously it'll give us a pointer and writes it to the TLS to say, please do not delete it. When we do the update now, we do exchange so that we put a new config pointer in there. And then here we cannot call delete. We have to call retire. This is the thing that will schedule on the background thread an expensive operation to go and ask everybody's TLS, hey, like, can I delete this now? And what's really nice about this is that on the read pass, we didn't really do much. This is all just writing a few pointers to the thread local storage. And what's also nice, this is a perfect example for hazard pointers, because our if, let's say, we do something for a while with the config, we just protect this one example of the config. It's okay that the system went away. And I'm out of time, but that's how you use hazard pointers for at least one object.